Let's get started. Throwback Thursday. October 6, 2010, Mike and Kevin created Instagram. It got acquired by Facebook in 2012. About a year after Instagram joined Facebook, 200 million people were using Instagram every month, and we were storing 20 billion photos. With no slowdown in sight, we began the integration. Our move from the AWS servers to the Facebook infrastructure. It saved us a lot of the AWS views. This will ease the integration with other internal Facebook systems and allow us to take advantage of the tooling built to manage large-scale server deployment. In 2014, we scaled the infrastructure from 1 to 3 data centers. To deliver a much-needed resiliency, our engineer team didn't really want to relieve the AWS disaster of 2012 when a huge storm in Virginia brought down nearly half of its instance. The next 36 hours after the outage was a brutal, basically rebuilding our entire infrastructure. That was terrible. I joined Instagram as a production engineer early 2017 and taking on the responsibility of keep scaling Instagram infrastructures among Facebook data centers. Well, scaling from 3 to 5 data centers was kind of easy for us. We just increased the replication factors, copy exactly same data from one region to another, and drop it down. I was thinking my life was too easy. And then later, the next data center, our capacity engineers come to tell us, sorry, our next data center is on the other continent. Well, scaling up is much more difficult when your next data center is out of the same continent you usually have. And that's the first time we scale out of the US. Here's the overview of the data centers currently in use for Facebook. When we started this project, we only have 2 data centers in European, there's Odense not ready, and it's only available this year. Let me give you an overview of our infrastructure. For every request coming into Facebook data centers, they go through our load balancer. We call it Partition. And then we use Django and USENIX as our web servers. Django is open source applications and based on Python. So we have our own limitations. Compared to a Facebook machines, which have like hundreds of threads with workers, we have about 50. So we have processes instead of threads. That means latency is really tied to our capacity. If one request takes longer, that occupies one worker, then no one else can utilize that worker. So we have a really, really restricted timeout for each request of 12 seconds. If this request doesn't finish after 12 seconds, we brutally kill it. Just tell it, please, suicide, go away. And then under Django, we use a lot of stateful service. Storage like Tau, it's our own graph storage. And Cassandra, it's open source and managed by Apache. And we have our own video infras, machine learning infra, some asynchronized task queues. Here, I'm going to focusing on Cassandra and Django because that's the open source version, and most of people use like Apple's or Netflix or eBay's. If you use a similar structure, you can maybe learn something from this talk. Okay, Cassandra at Instagram. While we use Cassandra a lot at Instagram, I don't know many of if you know, Cassandra was actually open source by Facebook. And then later in 2010, it handed over to Apache because Cassandra is a little bit hard to handle and doesn't really fit our use case, so abandoned. But then 2 years later, they acquired a company called Instagram, and then voila, Cassandra is back. And the engineer developed the Cassandra. They really, really hate us. Sorry. And this is how we run Cassandra before we deploy to Europe. Each data center has one copy, like I said. Before, when we increase the number of data centers, we just duplicate the data everywhere. And then many of you maybe know, like Cassandra offers tunable consistency levels. And we had quite a bit of use case content quorum requests, meaning they need to talk to the majority of the nodes to succeed. And our requests fan outs. So one user request could contain multiple Cassandra calls. Well, there's a lot of like Instagram products use Cassandra like live, videos, feed, direct. It's really essential for us to deliver our dog pictures and cat pictures. And we have a lot of fun with Cassandra. I still remember at early of the Instagram years, there's a requirement for Instagram employees to remember Justin Bieber's user ID. Because whenever Justin Bieber posts something, it caused some hotkey issues on Cassandra. And we have to go investigate, oh, that's Justin Bieber, and have to do some manual stuff to kill switch it. But now we're more mature and well-maintained, and no one ever remember any user ID anymore. Cool. Assume we use the same strategy to deploy Instagram in Europe. Here's our problem. Quorum requests will need to travel across ocean. In a word of replication 5, quorum need 3. In a word of 7, you need to talk to 5. And remember our requests fan out, so they need to travel across the Atlantic Ocean probably multiple times. And too many replications increase the operational complexity, not to mention like we just need to increase our data footprint from 5 to 7, and this number will only increase in the future of the turn up of DCs. I don't really remember how many DC we already announced as a Facebook in the future. Like data center is like 15, 16, including one in Singapore. So what, we're going to have 16 copies of Cassandra data? Not going to scale. The solution we settled here, we introduced a new service called Accio, which is already used by several Facebook servers to achieve optimal data placement. So Accio is a data placement service. It helps to determine how and when to move information in order to optimize the retrieval speed for the user around the globe. It helps reduce your data footprint by splitting the data set into logical units with a strong locality. We posted lots of like Accio papers and more details in our Eng blogs. Feel free to read it, more details there. So you might guess what we did. Well, we partitioned our data set. Instead of have one single Cassandra cluster, for example, feed cluster, now we have 2. One is Cassandra EU, one is Cassandra US, with no overlapping of the data. So if your users live in US, then your data will be only stored in Cassandra US partition. If you're living EU, then it's the same. Your data will only store in EU, so the data is closer to you and not duplicating anymore. So it's decoupling the number of DCs with the number of replications. Again, you can read the details about Accio on our website, but here I'm going to walk you through one single request and how does that work. So for example, a request coming to Django, now it doesn't know where the data located. So it will Django will send a locate request to Accio proxy, and the Accio proxy will talk to probably a cache layer and have like more than 80% of the cache hit rate. If it's a miss, then it will directly talk to the Cassandra location DB. This location DB cluster we have stored in every region. It's a really small cluster, so we will have a really short latency and almost like reduce the impact of having an Accio in front of every request. Now, if it's find the location, it will return it. If it doesn't find it, the default will be US. For example, some new user data, and we don't have it in the location DB. When Django have the location information, now it can directly access the right partition for the data. This is the synchronized path of trying to locate a Cassandra data piece. And under the hood, there's an asynchronized path. RQ proxy will try to track the accessing patterns and bump access counters for each request. For example, if you live in US, you will keep like hitting probably our Carolina data center or Oregon data center. Then RQ will know, oh, this user lived in US, so this data should store in the Cassandra US copy. But if one day you move to EU, and then RQ will be tracking the access, oh, this user is starting to request this data piece from a European data center, then bump the counter, and then decide to migrate this piece of data. So if this data doesn't find, then they will provision it in our location DB and create it, so next time it will be able to locate it. Cool. This seems like solved our problem, but our next challenge is how are we going to do disaster readiness in this situation? To give you a bit of a background, at Facebook, of all of our infra and all of our service, we have a goal is to be able to survive lose of any data center in any disaster. We will still be able to serve user traffic with minimum impact or no impact at all. This mainly because the disaster I mentioned, like Virginia, there's the huge storm, or the Florence hurricane in Carolina, they're really, really close to our data center. And then a couple years ago, we realized if those hurricanes hit one of our data centers, if we lose power, we won't be able to serve any user request or any service on Facebook. That was really, really dangerous. And many of you may say the features like mark yourself as safe in those disasters or any incidents or event. We won't be able to let our users still use our platform whenever what happened. So we started to practice disaster readiness at Facebook for every service. And it's the same for Instagram. So before we deploy to EU, we have this US data centers. Let's say like each region takes some portion of traffic, some 20%, some 15% based on its capacity. And they can fail over to any of other regions because each region has one copy, right? Now we have this EU region. Let's call it a traffic ring. And you can fail over within the ring because like within this ring, each region have a data copies you need. For EU, now we have 2 data centers. Say each of them takes 50%. They can only fail over to each other because, well, they contain each other's data. Now there's a problem. If we wanted to do this, that means each region need to prepare 100% of actual spare capacity to be able to take this kind of failover. That is a lot of the space we don't have. And our capacity engineer will definitely not give us that capacity to prepare this kind of scenario. We need to think of something else. Well, then, can we do something smarter? Like, let's utilize the US capacity because for the US data centers, they already prepared to take one region failure, right? So they already have the extra. Can we fail over to utilize, let's say, ASH or FRC, like Carolina, they're like really close to EU, not that close, but like close, it's nearest data centers. Well, to be able to do this, let's go back to our Cassandra deployment. We have this 2 partition setup, and in EU, we only have 2 data centers. 2 is really a hard number to deal with because we have quorum. And for Cassandra, if you deal with Cassandra before, you know sometimes I have down nodes, and we wanted to be able to still serve quorum requests when we have a single down nodes. So we decided to deploy 2 replications in each of the EU regions. In this way, even with 1 down nodes, we still have quorum requests can served out of the EU continent. To be able to fill over our traffic to US, we did this. We deployed 1 more replications in ASH. It's a data center in Virginia, and it's the closest data center we have to European the data centers. So in this way, even if we lose, say, Luleå, we still have 3 replications left and still be able to serve quorum requests. While yes, the quorum requests will cross ocean, but at least we can still serve them with a little bit worse of latency and performance. That's better than nothing, right? It's still not perfect. And some of our engineers says like, well, when you have the third data center coming online, can you completely split? Don't make the quorum request cross the ocean even when you lose one data center. This will be better, right? Like two completely independent rings and fill over within each other. Sorry, no. Because it's still same problem we have. If only fill over to 3 data centers, each of them need to prepare 50% of the spare. That's still a lot. And then there's another ideas coming from our capacity engineers, well, we really like your idea of fill over to EU traffic to US because you utilize a lot of the capacity, the Django capacity. Can we do the same for US? If you can fill over the US traffic to EU, then we will save a bit more of the Django capacity, right? Because we have, instead of 5 regions, now we have 7 regions to fill over and reduce the headroom from 25% to 16%. And then, further, we could just merge these 2 rings into 1 traffic ring. How about that? Not really, because it would just go back to our first question, right? Latency, replications, quorum always 100% of time across the ocean, and Cassandra replications keep increasing with the data center numbers. No. And then we got another opinion from our Cassandra engineers, we really like the idea of partitioning data set. Can we do more? Can we further partition our IGUS partition into IGUS East and IGUS West? In this way, we reduce the replication numbers from 5 to 3. And furthermore, when we have the Singapore data centers, when we have more data centers in Asia, we can have another traffic ring there. And then each of the partition will only have 3 replication. That's a lot of storage space we saved. No, because that will be too much of the Django capacity we need to prepare, and it's still the same problem. Sorry. So, our problem is really about trade-offs. You have to pick between latency, performance, or your compute, disaster readiness, and resiliency, and the storage. So some takeaways. If you really care about latency and performance, bring your data closer to a user. To make your service disaster resilient and be able to fill over, you should deploy to multiple regions. And the more regions you deploy to, the less headroom you need to prepare for failover. And you should partition data set to reduce replication. This will help you save a lot of storage space. And you can't have all. You have to make trade-offs. You have to find the balance in between and find the best solution for your own service and find a way everyone will be satisfied with. That's it. Thank you. Any questions?
Hey, how much latency does the Accio kind of dance add over just straight Cassandra requests?
It's less than 10 milliseconds. Yeah. So it's basically we can ignore it on the 12-second of limit of on Django request. Yeah.
Okay. Can we have the replication from EU to US, but the US nodes won't participate in the quorum, but they just replicate, but at the time of writing, it won't participate in the quorum? Is it a possible solution that you thought of?
Yeah, it's basically just depends on your service requirement, right? If your use case don't require quorum on some of the, or less quorum, or can even reduce quorum, you can totally do duplicate to everywhere. But for our service, we need quorum latency consistency and read consistency. So it's a decision made by our product engineers. They think this is the best for our product, and we're just there to like serve them and help them to provide this kind of service. So it's our business model, and we have to serve this like a large portion of quorum requests. That's why it caused this latency issue for us.